A pair of linear equations in two variables can be represented algebraically as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, where a1, b1, c1, a2, b2 and c2 are all real numbers, and a1 square plus b1 square not equal to 0, a2 square plus b2 square not equal to 0. And graphically, in the xy plane by two lines which can be intersecting or parallel or coincident with each other. Now, let's try to solve these equations. Now, for a linear equation in two variables, there are infinitely many solutions. So from this, we can infer that out of a pair of linear equations in two variables, each of them has infinitely many solutions. And when we combine the two equations, the solution will be the common values of the solutions of each equation. So we need to find these common solutions. How can we find out? Let's check it out. We had already discussed earlier that a pair of linear equations in two variables can be represented graphically in the xy plane by two lines which can be intersecting or parallel or coincident with each other. So, the solutions can be found corresponding to these three possibilities. Now, let's consider these three cases with three examples. If we consider the graphical representation of the first case is pair of equations x minus 2y equal to 0 and 3x plus 4y minus 20 equal to 0, the lines intersect in a single point, that is 4, 2. In the second case, x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0, the lines are parallel to each other. And in the third case, 2x plus 3y minus 9 equal to 0 and 4x plus 6y minus 18 equal to 0, the lines are coincident. Finding the solution in these three cases is same as finding the common points of the two lines in their corresponding graphs. Thus, the solutions of each of the three cases will be different. When the lines intersect in a single point, that is one and only one common point, the pair of equations has a unique solution. Here, it's the point of intersection 4, 2, where x equals 4 and y equals 2. Such type of pair of linear equations are called as consistent pair of equations. When the lines are parallel, there are no common points. The pair of equations have no solution. Such type of a pair of linear equations are called as inconsistent pair of equations. And finally, when the lines are coincident, all the points are common. That is, all the points of one equation is same for the other. And since each of the linear equations have infinitely many solutions, the pair of equations have infinitely many solutions. Such type of pair of linear equations are called as dependent pair of equations which are consistent. Now, for each three cases, let's compare the ratios of the coefficients of each pair of equations. That is a1 by a2, b1 by b2 and c1 by c2. In the first case, a1 by a2 is not equal to b1 by b2. This case is for intersecting lines with exactly one unique solution. Now, in the second case, we find a1 by a2 equal to b1 by b2 not equal to c1 by c2. And that's for the parallel lines with no solutions. And in the final case, a1 by a2 equals b1 by b2 equals C1 by C2. This is for coincident lines with infinitely many solutions. So we infer that in a pair of linear equations in two variables, that is a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0, if the lines represented by the equations are intersecting, then a1 by a2 not equal to b1 by b2. Parallel, then a1 by a2 equal to b1 by b2 not equal to c1 by c2, and coincident when a1 by a2 equal to b1 by b2 equal to c1 by c2. Now let's work out a problem. On comparing the ratios a1 by a2, b1 by b2 and c1 by c2, find out whether the lines representing the following linear equations in two variables intersect at a point are parallel or coincident. Also find whether these equations are consistent or inconsistent. Consider the first pair of equations x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Here a1 equals 1, b1 equals 2, c1 equals minus 4, a2 equals 2, b2 equals 4 and c2 equals minus 12. So a1 by a2 equals 1 by 2, b1 by b2 equals 2 by 4 and c1 by c2 equals minus 4 divided by minus 12. Comparing the ratios, we infer that a1 by a2 equals b1 by b2 not equal to c1 by c2. So they are parallel lines, and since there are no solutions, the pair of equations are inconsistent. Now the second pair of equations, 7x minus 15y equal to 2 and x plus 2y equal to 3. Comparing the ratios, we infer that a1 by a2 not equal to b1 by b2 not equal to c1 by c2. Therefore, the lines intersect. So there is one unique solution. Thus, the equations are consistent. And the last pair is 2x plus 3y equal to 8 and 4x plus 6y equal to 16. Comparing the ratios, we infer that a1 by a2 equals b1 by b2 equals c1 by c2. Therefore, the lines are coincident. So there are infinitely many solutions. Thus, the equations are dependent pair of equations which are consistent. So we can conclude that when a pair of linear equations are represented graphically, there are three possibilities, and their corresponding solutions are one unique solution when the lines intersect, no solutions when they are parallel, and infinitely many solutions when they are coincident, which makes them consistent, inconsistent and dependent consistent pairs of equations respectively. Also, the ratios of their coefficients a1 by a2 not equal to b1 by b2 for intersecting lines, a1 by a2 equal to b1 by b2 not equal to c1 by c2 for parallel lines, and a1 by a2 equal to b1 by b2 equal to c1 by c2 for coincident lines.